After spending time solving one-step equations, we're now going to shift our direction to inequalities. Let's recall that there are four symbols of inequality: less than or equal to, greater than, and greater than or equal to. We can graph inequalities on a number line, so we're going to be solving, finding a solution, and graphing. But before we do, let's just recall how to do the graphing. Suppose I wanted to graph the solution of an equation. Well, for the most part, an equation, when we solve it, has just one solution. So if x were equal to 2 as the solution to an equation, I would find 2 on the number line, and it would be this closed circle. This one point here is the only number that would make that particular equation true. Now let's move on to the x is greater than, okay, this is my greater than symbol. X is greater than 2. Well, I'm going to have now what we call an open circle and shade everything in the greater than direction. Notice that the symbol points in this direction, and so does the arrow on my number line. That's a good way to remember the greater than. And the numbers are getting larger, so that's our greater than symbol. We then could go on to the symbol that says greater than or equal to. It could be greater than or equal to 2. So in this case, we would go back to, think about if equal to was a solid circle, well then this includes this number 2 and everything greater than. And we should also recognize that the less than would go in the opposite direction. But I just really wanted to focus on the point that a closed circle represents including that number, whereas an open circle just states that it's everything going into the infinity of that direction. So we'll start by looking at a solution that's already been graphed. When I want to write an inequality represented by this particular graph, I always start by writing my inequality, an inequality with the variable first. So it says that x is, now I noticed it's a closed circle, which means it's going to have a line underneath, and it's shading in the less than direction. So x is less than or equal to -3. I look at my second problem, and again, the reminder is that you always write an inequality with your variable first. I'm still choosing x. You can pick any variable. I notice this time that it's an open circle, and it's shading in the direction that is getting bigger or greater. So x is greater than 4. The number where the circle is tells me what my boundary is. If it's open, it doesn't include 4. If it were closed, it would. Now let's look at graphing. Suppose I give you an inequality that says that x is greater than or equal to 3. How do I go about graphing that? I find 3 on my number line. I put a closed circle because of the line underneath, and I shade everything that is greater than. The shading is important because it says it's not just one number as a solution, it's all these numbers into infinity. A second problem. Let's see, we have x is less than -1, open circle, and shading everything less. So where did I start my graph? From that -1, and then from there I shade everything that is less than. So there we have 2 examples of each, of writing the inequality and also graphing the inequality. Let's go back to naming again. Try these 2. If you can recall, we said that we always write an inequality by starting with the variable. X is, I'm looking at an open circle shading to the left, which is less, -3. Second problem here, x is closed circle and shading everything greater than or equal to 4. What happens when we look at a problem and we're not sure? Well, look at those symbols and look at those hints. Open circle, shading to the left, left is less. Start with your variable, less than -1. This should come back to you pretty quickly. I'm sure you've all done this before. Now let's go back to graphing. So again, I'm going back and forth between the two so that you get a good example of each. I start at this problem and I see that n is greater than 2. Open circle because there's no line underneath, and shading everything that is greater. Try the next one on your own. Did you try this one? Again, -1 is where I need to place my circle. I then decide whether it should be opened or closed. Well, the line underneath tells me to fill it in. It's a solid circle. The arrow is pointing to the left, and left is less. I'm going to change up this next one. I'm going to write this expression says 4 is greater than or equal to n. Well, if you recall, when we write an inequality, we should always write our variable first. So if 4 is greater than or equal to n, n must be less than or equal to 4. We have to write our variable first, so that tells us where to place our circle and what direction to shade in. If I were to leave it the original way, I might shade in the wrong direction if I wasn't paying attention. So again, always write your variable first. Speaking of that, let's look at a statement so that we can remember that we can write inequalities in 2 ways. I'm going to write 2 inequalities to represent these numbers. And it's going to show a relationship between them. Let's pick the numbers 3 and 5. My first inequality might be 3 is less than 5. If I wanted to write a second inequality about this relationship, I would say 5 is greater than 3. So that's showing you that you can restate an inequality by reversing the direction of the inequality and switching the numbers. So again, if you're solving an inequality and you get 4 is greater than n, you rewrite it as n is less than 4. I'm going to leave you with that and a little bit of practice. And next class, we'll be solving the inequalities.